Hello, welcome to another Open Geospatial tutorial. In this video, I'm going to show you how to use the model builder in GeoLibre. If you have ever used ArcGIS model builder or the QGIS graphical builder, you might like this one. And the advantage of using the model builder in GeoLibre is that it runs entirely in the browser, so you don't have to install anything on your computer. And you can easily customize the workflow. You can create new nodes, you can delete new nodes, and so it's very flexible. And let's get started. First, you need to go to the GeoLibre website, geolibre.app. Then on the homepage, just click this Launch GeoLibre web, and then it should open this one in your browser. So let me close the previous one. In here, you only need to just go to the processing menu here. Then go to here, model builder. Just click this one. Then it should pop up this one. So here on the left side, you will see it has all the tools. So it includes 1066 geoprocessing tools, including 730 white box tools and also over 330 GeoLibre built-in tools. So in total, it has over 1,000 tools. And it's open source. It's totally free. You're welcome to use them. You can also contribute to the upstream, and you can move this one around here. You can also upper right corner here. You can just minimize it. It's taking too much space. Sometimes you might want to inspect the data. You can also click this button to maximize the panel. So in that way, you can see basically the full workflow if needed. So right now, I'm going to just restore to just this panel. In order to use that, you need to add some data. So or you can just start it with this one. Just click input, and then you can just select any tools that you like. If it shows you the red color, red means you need to set the input, or you need to specify the parameters. So right now, these are all seeing just the red color in here. So I can create a new, and then it's going to create an empty canvas. So before I do that, I can maybe just show you some simple data. So we can add some vector data. For example, I can maybe, how about this? I can add the Las Vegas building, and then just click load. It should be able to load some sample data. So then I'm going to open the model builder again. And from here, you can minimize this one so you can inspect the pixel value. And depends on how complicated is your workflow. So it can be just 1 or 2 or 3 steps, but for me, I'm just going to show you a simple one. For example, I can do how about this? I can get the input, and then so I'm going to set this one here. For example, upper right corner here, you can select this Las Vegas building as the input, right? And then you can drag this node around the canvas. The second one will be, how about like you want to create a centroid or something? So I can say vector, okay? Centroid, or maybe just so centroid. Okay, so here you're going to show you, okay, centroid vector, right? So you can just click this one, then you will create this new node. Upper right corner here, you can just click this one to the input, and that's it. So now you have this one, and you can create a centroid. Also, on the right here, it asks you whether you want to keep the result or not. Sometimes, if you have multiple steps, you just want to get the final output, then you don't have to click this one. But you can also manually click this output node here, and then I can just connect this one to the output. All right, and that's it. So here we have the input, and then we create the centroid, and then create the output. Of course, I mean, this is a simple demo, but you can have more workflow. For example, you can let's say you can convert the vector to points, and then you can extract the points or something like that. Once you have this, now you can simply just run this one. You can also click the arrange button here to arrange this one right now, right? So you can see that in your full view. After that, just click this run button and then see what's going to happen on the map canvas. So click and take a look. Within less than 1 second, you get all the results. And this can be applied to last data set. It's so much faster than other desktop GIS because they need to start and they need to warm up. Usually it takes maybe at least 10-20 seconds. It's not as fast as this one. This is entirely running in your browser using WebAssembly. So it's super quick. And you can get the result easily just using a couple clicks. And after that, you can export this one to your computer as a model JSON file. And after that, you can re-import them. So I can just create a new button. It's going to clear the model. After that, I can just click import and then go to my downloads directory. And now I load this one back into the model. So you can see how easy it is. And this is just a simple workflow. Next, I'm going to show you a more advanced one or more complicated one. So let me remove all the data layer. So this is using vector data. I'm going to add a raster DM. Go to add data and then the raster data layer. From here, I'm going to use the sample data set, the sample DM that I loaded. So once you select, it's going to load the DM automatically. So this is a DM in the Oregon state in the United States. Then you can change the color map. I'm going to use the terrain color map here. Okay, and so if you're doing hydrology, usually you need to extract, for example, the stream network. So you need to calculate the flow direction. You need to fill the DM first. So you create a depression list DM, and then the flow direction, flow accumulation, and then you set a threshold to extract the stream network as a raster, and then you vectorize the raster, and then you end up with a stream network that's a vector data set. This usually take a couple steps, and of course in the whitebox tools here, if you go to the whitebox tools, you can run this one step by step. You can code the tools. For example, you can say D8, okay, then just select this one, D8 pointer, so the 8 direction. Then you can just select the DM, and then you can start doing the calculation. But this is going to take some time because you need to run that one by one, and it's much easier to use the model builder because you can do things much faster. So we already have the model builder here. I'm going to expand this one in here. Maybe let me fully maximize. Okay, then we can start doing all the steps. Right now we can do it manually by searching the tools here, but later I'm going to show you how to use the AI assistant, so you don't even need to manually search them. First, let's get the input, right? So this is the input data, and then upper right corner, select the DM. All right. After that, you need to fill the depression because the depression, the DM might have depressions. So the depression, basically the water flow into the depression is going to get stuck. Before you do any hydrological analysis, usually you need to create a depression this DM. I'm going to search depression. Here it has multiple algorithms. It depends on which one you use. The traditional one is the field depression using the Wan and Liu algorithm. And so this is actually algorithm developed by my PhD advisor, Hongxin Liu, and his former PhD students, Lei Wan. And so I'm going to use this algorithm here. And so I'm going to connect all those. Maybe I can connect them right now. So if you want, right? So the DM, and then going to fill the depression. After that, you're going to calculate the flow direction. So this is called D8, D8 pointer. So move this one here. And then you want to connect the depression list DM, and then to calculate the flow direction over here. After that, we want to calculate the flow accumulation. So you will say flow accumulation here. So D8 flow accumulation, right? And then I'm going to cut from here. For this one, you can connect the D8 and then come to here. On the right, you need to check this box. It just says input is a pointer because you can also use the DM directly as the flow accumulation. You don't necessarily have to calculate the flow direction first. The reason is that I only show you all the traditional steps. So make sure that you check this one. Also for the output type, I want to check this cells because it's easier, much more intuitive. It's going to show you how many pixels that you want to use as a threshold to extract the stream network. All right, so now we have the flow accumulation. The next step is to extract the stream. So you just type streams. Then from here, you can have this one, extract streams, all right? And then from here, you can look at the output, the threshold here. I'm going to use maybe 1000 is the threshold. Then I'm going to click this stream network to this extract streams. And after that, this is going to be a rasterized stream network. And the last step is to connect, extract the stream as vector. So this is the one, raster streams to vector. So click this one, and then just connect here. All right. Oh, by the way, so for the raster streams to vector, it actually has two input. The first one is the D8, so this is the D8 pointer, and the second one is the stream raster. So what you want to do is to connect this pointer here to the first one, and then the stream network, the stream raster to the second one, right? And after that, at the end here, you can just click this keep result, and then you're going to generate the output. Or you can manually click this output nodes if you want to. I'm just going to use this one, so it's easier. Just click. Now we have the entire workflow finished. Click this arrange button to arrange it automatically. And if it doesn't look good, you're welcome to arrange it, right? So you can drag things on out if you want to. And the other thing is that it allows you to remove the node. So for example, if you don't want this one anymore, you can click click the edge. It's going to remove the node, and then this one becomes just an independent. So from here, you can just remove it. So then you'll be gone. So feel free to make adjustment. And so for this one, I do want to keep the result, so I'm going to connect to this one. And that's it. So after that, let's go back to this one here so you can see the result. I'm going to arrange it here again. Now let's take a look at this. We're going to run through the whole workflow. And when it's running, you will notice the node is being highlighted. Also, the input and output has the rounded corner. All the tools is just a rectangle, a perfect rectangle. So let's try this one. Click one. And right now, it's basically in here. Okay, now it passed to fill the depression, then create the flow direction, flow accumulation, extract the stream, rasterize, and done. Take a look at this, how nice it is. So just within a couple seconds, we have the stream network extracted perfectly, and it looks pretty decent. So it depends on how dense is the stream network you want to extract. You can lower the threshold. That means you're going to end up with more stream network. And so, for example, right now this is the one that we have. I can go back to the processing toolbox here, select this extract streams, right? So by default, this one is 1000. For example, I can change it to 100. Then you'll end up with a lot more dense, and you don't have to go through them one by one again. Just click one, and it might take a little bit longer because you're going to end up with more stream network, but this is how easy it is. All right, take a look at the next one, right? So the red color right now, this is the stream network with 1000 pixels. So certainly you're going to have a lot more things in here, and it's pretty cool, right? So this is essentially what the model builder is about, is creating reusable workflow so that you can just easily make changes. All right, so once you're done, you're welcome to, for example, I can just save this, export this one, this model, and then later you can import it if needed. So next, I'm going to show you how to use the AI assistant. Earlier, we just create these nodes one by one, but you don't even have to. You can just use the AI to help you create a workflow. I'm going to create this new, remove everything, and also on the layer here, I'm going to remove all of them. And then I'm just going to keep this the DM in here. After that, I'm going to go to the processing, open the AI assistant. So from here, you can just start asking the questions. If this is the first time you're using this, you need to go to the settings and then AI provider. So click this one. Then you need to set up the AI provider and also the tokens. I'm not going to show it here, but you're welcome to explore. You can use GPT. You can use Anthropic Cloud. You can use Gemini, or you can use a local Olama. So it's very flexible. You can use whatever AI models that you want to use. So for here, once you're done, I can start coming here. I can just type hi to make sure that it's working properly. You will see the AI assistant is doing, just say, ask, what do you want to do me to do with the DM data layer? It's pretty intelligent because I select this DM data layer in the upper left corner. If you don't know what to do, you can say, okay, what can you do? And then just hit enter. It will give you some hints what kind of things it can do. And the goal of this tutorial is to show you how to use the AI assistant to create models in the model builder, right? So he can create a hue shade, blah, blah, something like that. So I don't need all this. I can just ask, create a model in the model model builder to extract stream network is vector using dem.tif. Okay, as simple as that. And just hit enter. Let's see what happens. So right now we have this model builder opening here. It should be able to create a model, and bottom left here, you're going to see the steps. So first, you're going to search all the data layer right now in your layer panel. Then it's going to search all the algorithms. So it's going to do it one by one. It might take a couple seconds, but it's certainly still going to be faster than you're trying to create a model builder by yourself. And it might not always be perfect. You can always customize it. You can adjust the workflow if needed, but just let the AI handle that to give you the first draft. All right, so take a look. It says it's already done. It has the workflow, fill the depression, create a deep flow direction, flow accumulation, and then extract the stream cells using a stretch of 100 cells. By default, you can change it and then convert the raster to vector. So it's already here, right? And let me minimize this one. Then I'm going to maximize here and click the rearrange. And look at this, right? So it's pretty much the same as the one that we created. Almost exactly the same, except the extract stream. It used 100 pixels as the default, and the DA pointer, and also the raster stream to network. And let me look at the flow accumulation. So the flow accumulation actually is pretty intelligent. So earlier we used the we use the DA pointer to calculate flow accumulation, and then we check this box. But right now the AI assistant, it actually used the depressions DAM directly without having to use the DA pointer, and the flow direction is only used to rasterize the stream into a vector, right? And other than that, everything looks perfect. So let's take a look. So I'm going to just already rearrange and then just run it to see if we can get the same result, just like what we did earlier. And it's running, and take a look. It's the same, right? Same result, like the one that we just did earlier. And that's it. So I just maybe spend a couple seconds, just write the prompt and then create a model, and then it just generate the model perfectly. And then you can export the model as a JSON file, or you can customize it. For example, okay, right now I want to use maybe 1000, so 100 is too small, too many stream networks. So I'm going to run this one again and then get the same result. And rearrange it. Okay, so now we have the new one, the red color here. Let me turn off the previous one. So now we only have the main stream network, and this is how easy it is. So feel free to make adjustment. For example, you might be doing some LiDAR data analysis. There are a lot of LiDAR tools in here, so you can use that to create a workflow to process LiDAR data. Or if you might be doing some like spatial data analysis or remote sensing or whatever, there are a lot of tools available here that allow you to do all kind of analysis. So feel free to explore this and then use it to your advantage. It's free, open source, totally free. You don't have to install anything. Runs entirely in your browser. Over 1,000 geoprocessing tools, and you can use this one to do research, teaching, workshop, whichever you like. If you run into any issues, feel free to go to the GitHub repository, and you can report on issue here. I'll be happy to help you out. Okay, so that's all for this video. I will see you in the next one. Take care. Bye bye.